This is lesson 9-5, slope-intercept form. I think this one will kind of be a little easier one for you. Okay, so this right here is slope-intercept form. So I want you to write that down and write down that that is slope-intercept form because you will need that now and especially in Algebra 1 next year. But this formula is called slope-intercept form because we only need the slope and the y-intercept. It's named by what's in it. Okay, so once you have that, the m is your slope. That's what we've been doing. The m equals y2 minus y1 over x2 minus x1, your slope. That's m. B represents your y-intercept. So you might draw arrows to it when you write it, that m is your slope, b is your y-intercept. Okay, we're going to be using that throughout this whole lesson and probably from here on. So this first example just says state the slope and the y-intercept of the graph of y equals 1/4 x minus 6. Now we don't have to graph it. It just means of this equation, if you were to graph it, what is your slope and your y-intercept? So we look, it's already in that form. That's the first thing you have to check. Is it in y equals mx plus b form? And it is. That could technically say plus -6, okay? So it's in the right form. So now we just look. M, that's what's right here in front of your x. So our slope on this one, and we can just say m equals for slope 1/4. That is your slope. So your y-intercept, and you can now just say b or y-int, is what's over here. -6. Now, your y-intercept, I want us to get used to writing it and as a point. That is the point. Remember, y-intercept is the point where it crosses your y-axis. So on your y-intercept, your x is always 0. So this is the point 0, -6. Okay, I want us to get used to writing it like that too, because that'll be helpful for a few examples ahead from now. So go ahead and try 1A and 1B. Hopefully these shouldn't be too difficult for you so far. You're just stating your slope and y-intercept of the graph of each equation. If you're confused on a part, just try, at least put what you know, and then when I go over it, I think it'll make sense. Okay, so try 1A and 1B, and then I'll go over it with you. Okay, on 1A and 1B, we are just stating the slope and y-intercept. So they're already in the correct form. Okay, so my slope is just the number out front of the x, that's your m. So our slope on this problem is 3. Our y-intercept, which is where it crosses the y-axis, shut the door, is 1. That is a point. Okay, we've talked about that. Y-intercept is where it crosses the y-axis. So that is the point 0, 1. Okay, on 1b, my slope is -2. My y-intercept, there's nothing out here, so that means it would be plus 0. So our b, or your y-intercept, is 0, which means that's the point 0, 0. Okay, let's look at some more examples. Now looking at example 2, we're doing the same thing. State the slope and y-intercept of the graph of -4x plus y equals 2. But now, if we look, this is not in our y equals mx plus b form, which is what we want it to be. So what we have to do is rearrange this. That's why we've been doing this in past chapters. So we basically are solving for y. So I want to get rid of this -4x. I want to move the 4 and the x. So we look out front, it's negative. So we are going to add 4x to both sides of the equal sign. It cancels from this side, and I'm left with y equals. Now, you cannot combine these because this one does not have an x, so we have 2 plus 4x. But if we notice, that's not mx plus b form. The m and x need to go first. So you look at what sign it has. 4x is positive, so I keep it positive. This 2 is positive, so I have plus 2. So y equals 4x plus 2. It is now in y equals mx plus b form. So now we can actually answer the question, which is what is your slope and y-intercept? Our slope on this is 4, okay? And just remember, we write a whole number as a fraction by putting it over 1. Just telling you that because remember, slope on a graph is rise over run. You've got one number on top and one number on bottom. Just a little side note there. So it's 4. Our y-intercept is 2. That is the point 0, that's a bad 0, 0, 2, because it's on a graph where it crosses the y-axis. Okay, so on this one, we're still doing the same thing, but we had to rearrange it to get it in y equals mx plus b form first. So I'm going to have you try a couple of these. Go ahead and let's do 2a and 2d. Don't worry about B or C. So you are telling me the slope and the y-intercept of the graph of each equation. You're going to have to make sure it is in y equals mx plus b form first. So do those problems, and then I will go over them with you. On these, we're doing the same thing. We're finding our slope and y-intercept, but they have to be in the right form first. We don't know what our slope is yet, so we solve for y. So to get y by itself, I get rid of this 6x. I'm moving the whole thing to the other side. This one does not have an x and this one does, so I cannot combine those. Now, we want it in that y equals mx plus b form, so I have to switch them. You can actually just go ahead and write them that way from here if you want. It's negative 6x, and that's a negative 3, so minus 3. Now, my slope is negative 6, y-intercept is negative 3, which is the point 0, negative 3. Okay, on 2D, same thing. I've got to rearrange it, solving for y. It's over here, so I have to subtract 2 to the other side. So I have x minus 2 over here equals y. Even though it's backwards, that's still in the right form. Okay, my slope, well, just look, how many x's is that? There's 1. So my slope here is 1. My y-intercept is negative 2, which is the point 0, negative 2. Now we're going to look at taking that equation and using the slope and y-intercept to graph. So this just says graph y equals negative 2/3 x plus 3 using your slope and y-intercept. Now don't freak out when it's a fraction. To be honest, when they give us an equation and our slope is a fraction, actually makes it easier on us. So what we do, we identify our slope and y-intercept. Our slope on this problem is negative 2/3. My y-intercept is 3. That is the point where it crosses your y-axis, so that's the point 0, 3. So when you're graphing it, you graph your y-intercept first. Slope tells you what to do, okay? So you can't do something until you already have a point on your graph. So we graph our y-intercept first. That just means I go up to positive 3 on the y-axis and put a point. That would be my first point. Now, my slope is negative. When you are graphing your slope, think of it as being with the top number. So this means negative 2/3. So your slope, you're either always your top number, whether it's positive or negative. If it's positive, tells you to go up. If it's negative, tells you to go down. The bottom number just tells you how far to go to the right. So since this is negative 2/3, that means we would go down 2 and then right 3. For my next point, but you start at the point you just made. So from here, I'm going to go down 2 and right 3. That is my next point. Okay, all you need is 2 points on a graph to make a line. If you want to continue it, that's fine to get practice. So down 2, right 3. That would be my next point. Now, if you just wanted to see where a point would be the other direction, since you're going backwards, you would do your slope backwards. We would go up 2, left 3, just to see where it continued on that line. And then you would draw a line through it. Okay, that's how we graph an equation. So, excuse me. Then you would draw your line. So let's try one of these. This over here, I do like this since we've been talking about constants. Slope, this says constant of proportionality. The direct variation equation, which is what we just did last lesson, the y equals kx, is a special case of the form y equals mx plus b. The constant k is your slope, and y-intercept b is 0. So that y equals kx, direct variation, something has direct variation when your y-intercept is 0. That's all that's trying to tell us, is y equals kx is the same thing as saying y equals mx and then not having the b. Okay, so it just means something is directly proportional when your y-intercept is 0. Okay, I want you to try number 3. Obviously, you can't enter your graph on the computer, but you can tell me your slope and your y-intercept, but I want you to practice graphing it. So graph y equals negative x minus 2 using the slope and y-intercept, and then I will go over it with you. Number 3 tells us to graph using your slope and y-intercept. So first, let's identify those. It's in the right form, y equals, my slope is what's attached to the x, that's 1x there, so my slope is negative 1. My y-intercept is negative 2, which is the point 0, negative 2. Now remember, when you're graphing, slope is always one number on top, one number on bottom. So when we have a whole number, you always just put it over what? You put it over 1. So my slope here is actually negative 1 over 1. So when we're graphing that, you always start by graphing your y-intercept when you're using your y-intercept and your slope. Your slope tells you where to go, but you have to have a point already graphed to know where to go from. Okay, so my y-intercept is the point 0, negative 2, which means I stay and go down 2. There's my point. My slope tells me where to go from that point. So remember, your slope, if it's positive, you go up and to the right. If it's negative, you go down and to the right. It's always rise over run. The only time we ever go left is when we're just going backwards to add more points. So this is negative 1 over 1. So from this point, I would go down 1 to the right 1. That's my next point. And I could do several points. Down 1, right 1. If I wanted to know where it crossed somewhere the other direction, because this is a line, that's where you would just do it backwards. Up 1, left 1. But there is our line. We have now graphed y equals negative x minus 2. All right, example 4, everybody's favorite word problems. Okay, obviously that's a joke. I know you're not crazy about word problems, but they're not as difficult as they look. They just typically take a little longer because you have to read it. So it says a typical leopard gecko is 3 inches long at birth, and it grows at a rate of about 1/3 inch per week for the first few months. The total length of a leopard gecko, y, after X amount of weeks can be represented by this equation. So they went ahead and gave us the equation to represent everything they were just talking about. Y equals 1/3 X plus 3. And they told me X is the weeks, Y is the total length of the gecko. So the first problem, or first step, A, just says graph your equation. Okay, well, it's already in y equals mx plus b form. So we find our slope and our y-intercept, because that's slope-intercept form. My slope is 1 over 3. My y-intercept is 3, which is the point 0, 3. It's the same point we just did on example 3. Okay, so we would go on a graph, 0 up 3. There's your point. Now, if you notice, they only did the first quadrant because that is the only quadrant where x and y are both positive, because we're talking about how much a gecko grows over its life. It doesn't go backwards, like it can't go negative. So it's only positive numbers, so therefore you can just graph it like this. So we have the point 0, 3. Then my slope is 1 over 3, and it's positive. So that means I go up 1 to the right 3. That is our next point. I do like this over here. It says it only takes 2 points to make a line, but it's always wise to plot 3 just to confirm your line. So that's what I was saying on you really only need 2 points, but it always helps to make sure you're doing it right to go ahead and put 3 or more. So up 1 over 3, and so on. So then we could draw our line through that. Okay, so then B says describe what the y-intercept and slope represent. So it just means go back and look at what they were talking about in the problem for x and y, or excuse me, for y-intercept and slope, and then the numbers that go with it. So the y-intercept was 3, okay? So plus 3, because up here, he was 3 inches long at birth. So we started at 3 inches. So the y-intercept 3 just represents the length of the gecko at birth, what he started out as, okay? The slope was 1/3 because they told us he grew at a rate of 1/3 inches per week for the first few months. So our slope, 1/3, represents how much he grew per week in inches. Which should make sense because slope is the change in y over change in x, so that is how much he changed each week. Okay, so on that, you're just having to tell me what they were talking about for the y-intercept and slope in the problem. So now you're going to try one of these. I know word problems are not the easiest, so just try your best. That's all I ever ask on these. So you're going to try number 4, A and B, and then I will go over it with you. Okay, our last problem says Jack has written 30 pages of his novel. He plans to write 12 pages per week until he has completed his novel. The total number of pages written, y, can be represented by y equals 12x plus 30, where x is the number of weeks. So they give us our equation, y equals 12x plus 30. Okay, so A just says graph the equation. So in order to graph it, we need our slope and our y-intercept. It's already in y equals mx plus b form. So I just identify my slope in this problem is 12. My y-intercept, or b, is 30, which is the point 0, 30. So to graph that, actually being that we're talking about a novel and pages he's writing, it's going to be positive. You can't write negative amount of pages. So I'm just going to do the top part of the graph. And being that it goes all the way to 30, I'm going to count by 5s. If you did it, that's okay. This way, I guess I'll just count by 5s on both to make it easier. Okay, so my y-intercept is the point 0, 30. So I have 0 and then 5, 10, 15, 20, 25, 30. There's that point. My slope is 12. That's just one number. You need 2 for your slope. Rise over run. You need a fraction. So we just put 12 over 1. Since it's positive, that tells me I go up 12 to the right 1. So from here, I go up 12. So 5, 10. That would be 15, so 12's halfway between them, and over 1. So, boop, like right there on my graph. It's kind of hard to tell because that is 5. So then I can do it again. So let's see. 5, 10, 11, 12, over 1. So when we graph it, it's really straight line, almost up and down, but it's not because that would be undefined. Your graph should look similar to that. It might look a little different if you counted by something other than 5s. That's okay. Part B, describe what the y-intercept and the slope represent. So going back and looking at the problem, it says that he has written 30 pages of his novel. He plans to write 12 pages per week until he has completed his novel. The total pages written, y, is represented by y equals 12x plus 30, where x is the number of weeks. Okay, so if we notice, they already told us what they were. 30 was how many pages he has written. That was my y-intercept. Okay, so the y-intercept on this problem is the number of pages he's already written. Okay, the slope, they told us the 12, that was our slope was 12. That was how many pages per week he was going to write. So our slope is the number of pages he's going to write. So let's just say number of pages going to write each week. If you did not have these exact words, that is okay, as long as you had something along these lines. If you didn't, please write them down. Okay, so that will be the last example that we look at today. Here, I'll move so you can see that a little better, and you can pause it to copy that down.